Hey, this is Drew, and you might notice something different about this video. I'm in it. If you've seen my other videos, it's a lot of screen recording and technical stuff in Houdini and After Effects. I wanted to take a step back to some of the foundational stuff, the things that I've been teaching in college classes for the last few years. Today, and in the next few videos, we're going to be talking about color theory. Color theory is kind of an oddball in terms of art classes because there's a lot of physics and physiology and even psychology. There's also an element of unlearning as well. For instance, if you've been in an art class before and I asked you what do you get when you mix red and green together, if you said brown, you would be right. If you said yellow, you'd also be right. And that's because of the way color works and the different color models that we use. Before we can get into all the complex stuff like additive and subtractive systems, we need to define what color is and what it isn't. Let's start with a physical. In terms of physics, light is just different wavelengths of electromagnetic radiation. More specifically though, it's the set of wavelengths that we can actually see, or the visible spectrum. See, on the entire spectrum of electromagnetic radiation, we can only perceive a tiny sliver of that. UV light might give you a sunburn and some insects can see it, and radio waves are useful for Wi-Fi and a lot of other things, but we can't see that stuff. Being able to see it with our human eyeballs is really what makes light and color special. In a physiological sense though, we can only detect a fraction of that sliver. Inside your eyeball there's a retina, and inside that retina you're probably familiar with the cones and the rods that are photosensitive cells that allow you to see. Rods are generally sensitive to lots of different wavelengths of light. You can think of them as like the black and white photography of your eyeball. But then the cones are the ones responsible for color. There are cone cells sensitive to longer red wavelengths of light. There are cone cells sensitive to kind of medium green wavelengths of light. And then there are cone cells sensitive to shorter blue wavelengths. And that's it. Just those three. Three different wavelengths out of all of that huge electromagnetic spectrum. That's what we can actually perceive. So what about yellow? After all, it's a primary color. You can't just mix two other colors of paint together to create yellow. And what about purple? If red and blue are on opposite ends of this linear spectrum, with red wavelengths being the longest and blue being the shortest, why do they mix together to create purple? Shouldn't they just fade off into nothing? That's where the brain comes in and things get complicated. We can measure different wavelengths of light, we can dissect an eyeball and count all the different rods and cones, but we can't open up a brain and see how it processes color. And if we did, we wouldn't get any valuable information because that person would be dead, and everybody processes color a little bit differently. Since we don't have a roadmap for how every single person processes color, we use models to predict how most people will process color depending on the media that we're using to represent it. When you're in painting class and you learn that red and green are complements and you mix them together to create brown, you're learning a rule for one color model. In this case, the 12-step color wheel that most of us are familiar with. But that doesn't necessarily work outside of that color system, and that's not even the only color model that we use for paint. You might use the Munsell wheel instead, which has more primaries, and instead of green and red being complements, it uses blue-green as a complement for red. If you took a screenshot of this video and you printed it out on an inkjet color printer, it's going to use an entirely different color system. Rather than red, yellow, and blue as primaries, it's going to use cyan, magenta, and yellow. And rather than mixing those colors together and then putting them on the page, it leaves them unmixed and just puts dots of pure primary color on the page and lets our eye mix it itself. Even the screen that you're using to watch this on not only uses a different color model with its own primaries of red, green, and blue, but it uses a different color system. Rather than a subtractive system like paint or inks, it uses what's called an additive system. And in that additive system, red and green aren't complements. In fact, if you mix red and green together, you get yellow. Even though color models are pretty effective at letting us exploit the way the mind processes color and trick it into seeing whatever we want with just a few primaries, they don't work the same with every color system. They don't even work the same for every person. They don't even work the same in every environment. Lots of external factors influence the way that we see color. The main thing to remember is that color is not as quantifiable or universal as we like to think that it is. We need to be able to communicate colors, so we need to be able to differentiate yellow from orange. We also need to be able to reproduce color consistently, and so we give color names. But when we get past the 3 primaries and the 3 secondaries into tertiary colors, we're already starting to run into vague names like yellow-green and blue-green, or yellow-orange and red-orange. The fact is, color is an experience, and it's an experience that's somewhat unique to everybody. Seeing subtle differences between different hues or different values takes time. Over the next few videos, we'll get into all the complicated stuff like additive and subtractive systems, simultaneous contrast, excessive contrast, hues, values, saturation, color harmonies, discords, vibrating boundaries. Whether you're an artist or designer or just somebody trying to decide whether or not to go with white or eggshell, hopefully over these next few videos, you get a better understanding of how color works, how different colors interact with each other, how to describe and define color, and how it interacts with the environment. Hopefully you found this video helpful, and if you did, like, subscribe, etc. This has been Drew, and I'll see you in the next video.